In your next student practice number 1, your first activity for today, you're going to be using box method that we can see here, these box diagrams, to show that quadratic expressions in factored form and standard form are equivalent. And then you're going to make an observation about the connection that you're seeing between the factored form of the expression as well as the standard form. So what I'm going to do for us now is just kind of review how do we use these box methods to make sure that you're good to go for that first student practice number 1. So the first thing it asks us is, looking specifically at this box here, what expressions does this box represent? So everything's filled in and labeled for us. All we're going to do is simply identify what expressions does this represent. So as a reminder, my outside terms of this box that are labeled on the outsides represent my expression in factored form. So this is one factor going across the top. Another factor is going down the side. Each factor is on the same side of the box, meaning that this x and 2 is one factor, this x and 3 is one factor. Never combine terms from different sides. So we would never combine this x and x over here in terms of factors. We're always looking at specific sides of the box. So one factor I have here has this positive x and a positive 2. When we're writing out these factors here, I'm going to label as x, and then I need a sign. In my factored form, we always see x plus a number or x minus a number, so I need a sign here. Since this does not have a negative, it means it's a positive. I need to write in that positive sign, that plus sign, and it's plus 2. And there I go. That's one of my factors that I could just easily read off of the outside of my box. My other factor is going to be on another side of the box, and I clearly see this is a positive x and this is a positive 3 because I do not have a negative sign. So I'm going to write down my x, and then in between the x and the value I must have a sign. So this is a positive 3, so I'm going to go ahead and label that plus 3. And this is a quadratic in factored form. So there we go. One of the expressions this box represents is this quadratic in factored form. We also have a quadratic in standard form written in here that's equivalent to the quadratic in factored form because the standard form is made using the box from the quadratic in factored form. So what we're going to do is we're going to go ahead and figure out what standard form of a quadratic is represented here. So I need to combine like terms. So first thing I'm going to do is I'm going to write out all my terms. I have an x squared, so I'm done with that box. I wrote it down. I have a 2x and a 3x plus 2x plus 3x. I'm going to cross them out because I've written them down, and I have a positive 6. So I write plus 6. A common mistake that I see, and I have been seeing on a lot of your guys' papers, is that you'll write your x squared, you'll write your 2x, 3x, and 6. Notice how there are no signs here. We need to write this as an expression, adding or subtracting the terms. So whenever the terms are positive, here there's no negative signs, we're always writing plus in between each term. Don't write your terms out without putting the signs in between. Okay. All right, so my last step here is to combine like terms. X squared does not have a like term because it's the only variable here with a power of 2. 2x and 3x are like terms. They're both values being multiplied by x to the first power. So these are like terms. I can add them. 2 plus 3 is 5. So I have a 5x and I have plus 6. So this leads me to my final expression in standard form of x squared plus 5x plus 6. And there I have it. So from the box, I was able to easily find out that I have an expression here in factored form, x plus 2 times x plus 3. Notice how this is my form with the 2 sets of parentheses, as well as standard form where all I had to do was add up those terms inside and combine like terms. I know that these two quadratics in both factored form and standard form are equivalent because of this box here. It proves it. So the next thing that we're going to do here is we're going to look at what expression is represented from this box. So far my box is not filled in. So the only expression it's currently representing is the quadratic in factored form, which all I need are the terms on each side of the box. So my first factor, looking on one side of the box, is going to be x, and I have a -6 here. So my sign in between the value and the x is literally -6. So I'm writing out -6, close parentheses. That's one of my factors, what's written across one side of the box. My other factor is going to be what's written on this side of the box. I have x, so I'm going to use my parentheses again, x and -2. So this box so far is representing the expression x minus 6 and x minus 2 in factored form. The last step we're going to take here is a reminder, how do we fill in this box? How can I find the equivalent expression in standard form like how we did here when it's not given to us? So I need to go ahead and fill this in. Keep in mind that whenever we're filling in these empty boxes here, empty rectangles in the larger box, I am always multiplying the terms. So this empty box is below this x and next to this x. So I must multiply the terms together. X times x gives me x to the power of 2. Now I'm going to fill in this empty box. It's below the -6 and it's next to the x. So I'm going to multiply. X times -6 is just -6x. And then this empty box below the x next to -2. So I'm multiplying those two terms. X times -2 is -2x. And then lastly, this empty box is below the -6 and next to the -2. -2 times -6 is +12. A negative times a negative is positive. So again, keep in mind, to fill in these empty squares, I had to multiply the values that the box was underneath and next to. My last step to get my quadratic in standard form here is to add my like terms and write this out as a complete quadratic in standard form. So I'm going to list all of my terms that are in the box here, and then we're going to see how we can combine and simplify it. So I have an x squared. I wrote it down, so I'm crossing it out. I have a -6x, so I'm writing that down, crossing it out, a -2x, and a +12. And again, I'm putting next to each term whether it's positive or negative, so I have the signs in between the terms. All right, so it's all written out, ready to be simplified. X squared cannot be simplified. There's nothing else to a power of 2. The 12 constant cannot be simplified because there's no other value here that's just plain without a variable. -6x and -2x can be combined because they are both values being multiplied by x to the first power. -6x minus 2x, we're getting even more negative, is -8x. So I'm going to write this out in its final form. Oh, focus. We have x squared minus 8x, using this down here after combining, and then plus 12. So what I was able to do here is find that this box now represents the x minus 6 times x minus 2 in factored form, as well as x squared minus 8x plus 12 in standard form. This box proves that these two quadratic expressions are equivalent because after multiplying my factored form within the box, I do get this. So on your next activity, what you're essentially going to do is you're given two expressions, one in factored form and one in standard form, and it's going to ask you to show that each pair of expressions is equivalent. So for example, let's say you're given x plus 1 and x plus 2, and it's asking you to show that this is equivalent to x squared plus 3x plus 2. The way in which you're going to prove this is using box method. You are going to draw out your box, and you are going to label your box using your factored form. So on one side of the box, you're going to have one factor. On another side of the box, you're going to have the other. So here I have x and positive 1. I have x and positive 2. I'm going to split my box. And what you're going to do to prove that this is equivalent to this is multiply it out, add your terms, and see if it is in fact equivalent to the given standard form. And that's what you're going to go ahead and do to show this. So I recommend you draw this out in your notebook. I do need to see the box and how you filled it in, and then your conclusion of whether or not it is equivalent. I am going to attach another video here. If you do not like having to take a picture of your notebook and upload it, there's a way in which you can use an online whiteboard and then just take a screenshot. So I'm going to post that video next as well if you need to see that. If not, go ahead and just draw your diagrams out to answer the next question and be prepared to upload photos of your work. Go ahead and get started.